Okay, we're going to walk through this problem step by step using dimensional analysis. So the prescription is for Augmentin 0.35 grams PO. The pharmacy supplies Augmentin with 125 milligrams per 5 ml, and we need to calculate how many mLs the nurse will give and round to the 10th. So to start out with, if you're reading all that and getting overwhelmed, we don't really need to know all of these words and terms. We just need to pull out our numbers. With dimensional analysis, the very first thing we need to figure out is what are we solving for? So looking at this problem, I can see it's asking me how many mLs we're going to give. So I'm solving for ml. I'm going to go ahead and write that as my first step. And I'm going to start drawing my first box. One of our rules with dimensional analysis is whatever we're solving for, that unit has to go in your very first box. So I know right here I'm going to need milliliter. So I'm looking back at my problem to find where I have ml, and I see it right here with 5. So I'm going to fill that in right here. Okay, underneath in the box below, I need to add in the sister or partner to 5 mLs, meaning what number goes with this value. A lot of times we can identify the sister or partner when we see a slash, the word per, or the word in. I see right here a slash that was with my 5 mLs, so this right here is the sister or partner, and I'm going to put that in my bottom box, 125 milligrams. Okay, that goes right there. Now, the other rule I know from dimensional analysis is whatever unit is on the bottom also needs to go on the top. So I need milligrams right here. I have milligrams on the bottom, I need to put it on the top. So I'm looking back at my problem and I don't see any value that has milligrams. I don't have a number I can plug in right there. Instead, I have grams. So what I need to do is fill in a conversion. Anytime you need to fill in a value and you don't have it in your problem, that's when we need to fill in a conversion in that space. We call that like a Band-Aid, right? Our conversions are our Band-Aids. We have to put it over top our hole so we can keep calculating. So I don't have milligrams, but I do have grams. So I'm gonna do a conversion to convert milligrams to grams. These are things you just kind of have to memorize and know. For this problem, we know 1,000 milligrams is equivalent to 1 gram. So that's what I'm gonna fill in right there. Now my milligrams have canceled out, but I still have gram at the bottom. So I need to put gram at the top. Now I'm gonna go back to my problem and find where I have a gram value. Right here, 0.35. So that's what I'm gonna fill in. Okay, now my grams cancel and my milligrams cancel, and all I'm left with is milliliter, which is what I'm solving for. So that tells me that I'm ready to multiply. Okay, so for our top number, we're going to do 5 times 1,000 times 0.35, and that equals 1,750. Okay, then for the bottom numbers, I have 125 times 1, which equals 125. So we're going to divide those two numbers. We get an answer of 14. And that is our final answer. It asks us to round to the nearest tenth, but since we have a whole number, we don't need to round or do anything further. Remember, adding a trailing 0 or a 0.0 on the end to add a tenth is a big no-no with medical math, because it could end up looking like 140 and cause a med error. So no trailing zeros, we're gonna leave this at 14, which is the final answer.
Okay, let's look at this question. A PCP prescribes ibuprofen 600 micrograms for a headache. The pharmacy supplies 100 milligrams per 5 mLs. How many mLs will the nurse administer? We're gonna give you guys a second to work on this, and then we'll come back and show you the answer and work on it together. Now that you all have had the time to work on it, I'm going to explain this problem so we can kind of see together how we did. So, a PCP prescribes ibuprofen, 600 micrograms for a headache. The pharmacy supplies 100 milligrams for 5 mLs. We're solving for how many mLs the nurse is going to administer. So first we're going to start out with what are we solving for? mLs. mLs equals. One of our always rules is that we always put in our first box what we're solving for. So we know we're solving for mLs. We're going to put mLs here in our first box. Let's look up here in the question what we have that can go in that box. We have 5 mLs. What is 5 mLs sister? Well, we see this little dash here. Anytime that we see a dash or a per or an in, we know that probably means that those two numbers are sisters. So we see 5 mLs and there's a dash in between 5 mLs and 100 milligrams. So 100 milligrams is 5 mLs sister. Put 100 milligrams down here. Another always rule is that when we have a unit down here, we have to put that unit up here so they can cancel each other out. Put milligrams up here. So now we need to look in our problem to see where else we have milligrams. So a PCP prescribed ibuprofen 600 micrograms. That's our only other number we have. That's not a milligrams, but we can convert micrograms to milligrams. So we'll do our conversion. We'll plug in a Band-Aid. So we have micrograms down here. Well, we know that 1 milligrams equals 1,000 micrograms. If you have more questions about conversions, you can go into our conversions video and see where all those conversions are. So we have 1 milligrams equals 1,000 micrograms. Well, with our always rule, we know that micrograms, if it's on the bottom, it has to be on top. Then we go back to our problem. We see 600 micrograms is in our problem. We can put it in here, plug it in. Now, we don't have any other numbers left in our problem here. Are we done? Well, let's double check. We can mark out micrograms, can mark out milligrams. The only thing we have left is milliliters, which is what we're solving for. So we know that we're done and we can go ahead and multiply. 5 times 1 times 600 equals 3,000. And then 100 times 1,000 equals 100,000. Then we need to divide 3,000 divided by 100,000. And that equals 0.03. This problem doesn't ask what we need to be rounding to, so we're just going to keep it as 0.03 mLs. And that's our answer.